Hello and welcome to SystemVerilog in 5 minutes. In this video, we're going to talk about non-blocking assignments. This is a simple module. There is a variable a. In the initial block, it is set to 1 using equal symbol. This usage is very common in many coding languages. In Verilog, this is known as blocking assignment. And there is another one which is called a non-blocking assignment. This could be a rather confusing concept. For example, these two pieces of simple code cannot demonstrate the difference between blocking and non-blocking assignment. One way to understand non-blocking assignment is by understanding how simulator handles it. For that, you can refer to this video, but today we'll use a different approach. This is a simple design. It has input clock, input A, and output C. And for discussion's sake, let's put a point B here. We can describe the design in a structural manner. Assume we already have a primitive for the flip-flop and it is called DFF. We instantiate one DFF where it is connected to clock A and B, and C is assigned to B. Simple. Now another design. It is almost the same except it has an extra flip-flop. This is the respective code. This code and this code are different. They represent the design quite clearly. No confusion there. Now let's use behavioral modeling, and first let's understand the behavior. For this design, when the clock rises, A practically gets to B and then to C. For this design, however, A gets to B and at the same time B gets to C. A does not get to B and then to C in the same clock. It stops at point B and it needs a subsequent clock to get to C. Now back to here. For the flip-flop, we can use an always block, and this part is a continuous assignment. We can also model it this way. Behavior-wise, it's the same. Now for this design, you may think you can use two always blocks, but it does not work, because there's no guarantee which always block will execute first. If this always block executes first, then A gets to B and then to C at the same clock, and that's not correct. We can use one always block, and we specifically put this line first, so B gets to C and then A gets to B. But since they happen in the same clock, it looks like they happen simultaneously. This seems to work, but not really. If you tell me this code gets this design and that code gets that design, it's not intuitive at all. And more importantly, in a real design, there are other modules using the same clock driving A or sampling C. They would have their own always block, and we still circle back to the same problem. And that's why non-blocking assignment is introduced. Generally, non-blocking assignment is used to model concurrent behavior in a design. In this case, when a clock or event happens, these two assignments are executed concurrently instead of in a step-by-step manner. You can write the code in this way or this way. The assignments will work the same. Let's look at this example to understand better. We have four int a, b, c, d. At first, a, b, c are 1, 2, 3 respectively. When a clock or event happens, A gets to B and B becomes 1. Still at the same event, B, which is now 1, gets to C. Similarly, C, which is now 1, gets to D. If we compare to the values before the event, A gets to B, C, D like a simple combinatorial logic. On the other hand, if we use a non-blocking assignment, these three assignments happen concurrently. A, which is 1, sets B to 1. But the value A does not get to C at this clock. C gets the previous value of B, which is 2. D gets the previous value of C, which is 3. This creates a pipeline behavior between A, B, C, and D. Now before we stop, please do not mix blocking and non-blocking assignments. If you come across it, you should know the behavior is different depending on if the code is in the module or if it is in the program. Please refer to the scheduling semantics video. That's it for this round. Thanks for watching.